So today, looking at a few more data-related things. And so stem and leaf plots, maybe you remember them from before. They look like this here. And pretty much what they do is they take and have all the numbers except for the last digit in the stem. So that's going to be the stem part. And then the leaves are going to be a list of all the different last digits. So we have divides the data into two parts. All the numbers except the last are the stem. And the last digit of each number make up the leaves. And we have two different types of those. We have like the single stem and leaf, like this one over here on the left. Then we have the double stem and leaf, which would be this one over here. So this one here, they're looking at like number of students in elective classes. So these are all the first digits. And then the leaves are just going to be the last digit. So we have 0, 9, 1, 2, 1, 4, 1, 8, 1, 8. Does that sound familiar? So if you wanted to list them all out, you could. It'd be 9 for that first one. You don't have to write the 0, 9. And we have 12, which is the 1, 2. And then we have the 1 and the 4, gives you 14. And then the 1 in the first 8 is 18. You with me? Yeah. Another 18. So you could list them all if you wanted to. You could bail partway through. But when you have the 3 4s, it's just telling you that there's 24 3 times. 25, 27, 28, 32, 34. Good? So that's the first one. We probably won't go through and like list all of them for the second one, for example, too. But for now, they have what they call a double stem and leaf. So the first digits are here, and there's a couple changes with this one. One, the first digit we actually have is 2. So if we want to do these three numbers, it's actually going to be 124. And then the next one still has the 120. That's the 12 part is the 120, but then 128, and 129, then 130, ... Is those okay for Bill? But now they take and put another person's bowling scores as well, Marty over here, where now we have 120 is my 1, 2 still, but then this 1 over here is 121. Then we have 123, so the 1 and 2 is the 120, so 123. We have the 127, and then next we'd have 134, so the 130. And you'll notice a couple things. One, notice a bunch of things, I guess. What am I trying to say? So one, if they have more than one, if it's more than a 2-digit number, if you have 3 or 4 digits, all the digits but the last are in the stem. Good? If you have like a double one, so over here they put the smallest number, because these go in order from the stem out. They do the same thing here. So the smallest last digit, next smallest last digit, and so on. So I always have the smallest closest to the stem working out. And you'll notice, are there any scores in the 150s? Nope, because we have the 1-5, which means 150, and then there's no numbers after it. But they still put that number in there, even though there's nothing in that set of 10. Range of 10. Okay for those? Awesome. Frequency table. Just need to do notes. Right. So frequency table. A frequency table is really just a data table, but it's a data table that has a column of numbers and a column for how many times those numbers occur. For how many times those numbers occur. And sometimes you'll see a frequency table where they'll go through and they'll actually put in hash marks. So the first one would look like 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. You don't have to write in the hash marks, but sometimes when you're trying to count, it's nice to just do the hash marks, and then you could total them up at the end. But so golf tournament scores. You can tell which one would be my score right there, the 1 and the over 80. Okay. So that would be a frequency table. So 3 people scored. So 3 people scored in between 68 and 70. 4 people had a 71, 72, or 73. 6 people had a 74, 75, 76, and so on. Work for you? Awesome. Turn the page. A histogram is pictured example 4. Get it in color in my version. But a histogram is really just what kind of graph? Bar graph. So it's a bar graph. And really, it's just a bar graph that ties into one of those frequency tables. It's a bar graph that shows how frequently a value occurs. So this would be the same data as what you just had in that last frequency table, that you have one person here that scored in the 80 to 82 range. You have two people that scored in the 77 to 79 and so on. Good? What they try to do is, you'll notice for these, there's a couple things. Oh, I should probably go up to my notes. So it shows how frequently a value occurs, period. Data ranges should be equal intervals. Later on in this chapter, we're going to get to what are ways that people can manipulate graphs to make the data look different than what it is. One of them is going to be, if you were to take and combine these all together and have that just be one bar with a range of 6, it's going to look a lot taller than this one here, because it would have a total of like 7. It would be up to there. So you have to make sure that your distances on your x-axis are the same for each of them, that each of those on there is going to be 3 different scores possible. Fair enough? And so bars will be equal width, and bars will be equal width, and touch but not overlap. And the reason they try to do that is because the numbers are all in order. There shouldn't be a gap between the highest number here, 70 and 71. In golf, you either have a 70 or a 71. You can't have like a 70 and a half. So they try to show that by having the bars all touch each other. Almost done. We okay on the histograms? So when they say make a histogram, they really just mean make a bar graph of the data. So cumulative frequency table. I must admit, I was a little skeptical when I was going through the book and looking at the notes for this. It's kind of like, really? When is that going to come in handy? But sometimes it can. So a frequency table with a column for the total in that total number in that value or before. So in other words, if you're looking at basketball players' heights, we're going to say there's 6 people that are between 68 and 70. So cumulative would be 6. If there's an additional 8 people that are 71 to 73, what they do is they add the 6 and the 8 together to get the 14. So the 14 tells us there's 14 people that are up to 73 inches. Fair enough? If 5 more people have a height between 74 and 76, then you take and add all 3 of these together to get the total that have 76 inches of height or less. Fair enough? So without all kinds of people bickering and complaining, it's not as hard as maybe you think. So this is telling us there's 6 people with this height. Fair enough? Now, if you go up, here's another height. There's 8 people that are between this in height. The cumulative frequency is going to be, well, what's all the people that are this or anything above it? Yeah. So 6 plus 8 gives you the 14. If we have 5 more people that are between 74 and 76 inches, this is going to be the total that fits all the ones above. So 6 plus 8 plus 5 gives you the 19. So I wouldn't worry about their little arrows necessarily as much as this here's the total for this and all the ones above it. Then if they have one more person that's 77 to 79 inches in there, then they'd add one more to the total to get the 20. Yes?